We're going to talk about reinventing manufacturing today so you can build anything you imagine tomorrow. My name is Marcus Brown. I'm with MLC CAD Systems as a content strategy specialist. With me on the phone today is Mike Cady and Kevin Smith. They're going to be taking a deep dive. Mike's going to kind of show us the difference between the industrial and the desktop platforms. But let me tell you a little bit about MLC CAD Systems first. We sell and support SolidWorks, Mastercam, and Markforged products. Each one of these we selected as being sort of a leader in the industry. They provide tremendous value not only to companies in manufacturing space, but to companies that have each one. They all work really well together to give you a very robust solution set. The agenda today, we're going to talk about how exactly you reinvent manufacturing and some of the steps that you need to take to get there. And then we're going to take a deeper dive into the desktop and industrial platforms to talk about the solutions that are being provided by Markforged. Let's talk a little bit about how technology evolves over time. So think about like a computer. Initially, when computers came out, man, you needed like a PhD to operate them. They got to be a little bit easier, but you still needed to understand programming until it reached a certain point. Then it got a little bit easier for normal people. Eventually, it continued to improve to become sort of an integral part of our daily lives. It expanded to reach multiple industries. But the new technology, with its automation built in, the instructions are basically take it out of the box, plug it in, and we'll walk you through the whole thing. And a lot of times it's easy to lose sight of how much automation and how much simplicity has been built into the products that we use today. Luckily, because 3D printers are built on top of computers, we can take advantage of a lot of those big strides. So we don't have to go through the entire pain and development like the computer generation did. We can kind of jump ahead to the current technology and leverage it to make really great products. So if we look at that from the perspective of additive manufacturing, it started out very experimental. You basically either had to build your own 3D printers or you had to pay, millions of dollars to try to get one of the early models. As it started to get more mainstream, we saw a lot more people get really involved in the creation of the actual 3D printers. In a lot of cases, I think people were a little bit more excited about building the printer than actually building parts. And as those solutions and technologies became more robust, we saw additional industries pick it up and adapt it to their needs until we've really seen this become kind of its own major breakthrough and revolution in the world. But we're going to focus today specifically on manufacturing. In other words, building parts and products for people, for companies, and using additive manufacturing to support that manufacturing process. And there's a few ingredients that you need to be successful, which Mike's going to talk a little bit about later, but you need to have the right people in place. And in order for those people to be successful, they need to have a solution that's easy enough to use that they don't need to become additive experts. We want your experts to learn the printers and be easy and ready to run. You need to have some processes in place. There's a lot of growth and learning, as well as a lot of background activity that needs to take place before you can fully leverage a 3D printer for your production environment. And then, of course, you've got the technology that goes along with the people and the processes. But with a Markforged platform, the ingredients are really there and they make the other two a whole lot easier. Now, it's hard to really wrap your head around what that means, so I'm going to take you through a day in the life of a fictional company. So this is me at my fictional company. We're not a company that specializes in additive manufacturing. We just happen to be a company who has seen the benefits, we adopted it, and we're continuing to expand it as it makes sense for our organization to support our operations. I'm an engineer. You can tell because I probably wrote it on my clean hard hat. I probably have like a alma mater written on my polo, but basically anyone in the company is going to start to see the benefits from additive manufacturing. Some are going to be more involved than others, obviously. Now, as an engineer, I've got a lot of resources at this company to be able to solve the various challenges that come my way. You may start out with the R&D lab, which is typically the home of a lot of companies' first machine, their first 3D printer often ends up in R&D because it adds a lot of value in sort of fit, form, and function, as well as prototypes. But we need to look beyond the R&D lab if we're going to really take advantage of what additive manufacturing can do for a company. But in the R&D lab, it's all about reaction time. You want to be able to have your machine, your part, being able to quickly build what you need to get your job done, and you don't want to have to spend a lot of time operating your equipment. So where you used to have like a manual mill that I could go out there and mill my own parts, now I just go ahead and print it because it's a whole lot faster for me with a higher quality. And as an engineer, I've got other things that I need to be spending my time on. Then you've got the external vendors. Every company's got them. Most of the time, this is because you don't have that capability in-house. It could also be that you have a production sort of overflow that the vendor helps you with. Now, these vendors, they're experts in what they do, so you're going to end up with a higher cost and quality than what you would be able to do with just somebody running a manual lathe. But the lead times are longer. You've got to communicate more, which is a little harder because they're not your employees. You've got to worry about purchasing overhead and billing and things like that. It's not as simple as simply walking over to a machine and building it yourself, but it adds a tremendous amount of adaptability to your operations. Then you've got kind of your full production system. You've got a bunch of different production lines, but on that production, you've got high dollar equipment. You've got high volume production. This is where your money is being made. Right? There's a lot of opportunity cost there. And additive manufacturing, in a lot of ways, is designed to sort of stop bothering and stop interrupting the production line, but also to provide value, because every improvement you make in efficiency and speed in the production line is going to pay dividends over time. It's just making money. So the production line is always available, but we don't want to bother it as much as possible. Now, what is different probably from what you guys are used to as a manufacturing company is probably that additional department that we've created called the printing department, the Additive Manufacturing Group. That group allows me to create complex parts that are simple, fast, and cheap. Now, a lot of times with additive manufacturing, you think about the limitations in terms of the size, or being able to put a high quantity of parts through, or the material strength considerations. But that's where Markforged really shines. And as you sort of get ramped up on additive manufacturing, a lot of those considerations go away. So let me show you what this would look like while solving specific problems. So we'll start by saying we've got a brand new design and we want to build this new experimental design prototype and then test it out. Well, this is kind of the classical, this is what 3D printers are for, right? You want to be able to build anything in no time flat with no tooling or anything like that. Perfect situation where you want to print it. But if you can print it in a strong functional material, you can actually take that part and not just do fit and function. You can actually go and start testing it. You can actually start running it in the R&D lab. You can check and see if it's going to give you the results that you need without having to fully tool up beyond simply a toy or a placeholder that you might get off of a low volume or low quality machine. So let's say you've taken that experimental new design prototype and you've got it built, but you need to cycle test it to make sure that not only the design, but also that 3D printed version of it is going to be able to function. And you know, if the 3D printed version is going to function, if you make it out of metal later, that's not going to have any issues either. But being able to build that cycle test bracket with whatever design or shape or undercuts or complexity you need gives you the ability to create the part you want with no compromises based on manufacturability or complexity or time. The complexity is free. And you can go and build that quickly there in the lab with the printer and get your work going again and take your time doing other things, solving other problems and performing design. Now let's say you go more into the production area. So let's say you've got a design variant for a special job, and depending on who you are, what company you work for and what industry, everything is a special job, right? There is no like standard job. But in the case of a lot of machines, like for example, sheet metal, it's very easy to create a design variant. You simply create a new flat pattern and send it out. They'll know how to bend it and everything's going to work out just fine. Same with the vendor. Just give them a quick rev, give them a quick design change. They'll accommodate that without any major issues. But as the complexity of the change and the quantity needed start to diverge, right? Big change with a very low quantity, that's where it would really be helpful to have the ability to do production printing. And by production printing, I mean you're actually shipping products with printed parts out the door. Now, the only way you're going to be able to switch over from your standard production capabilities to a printed capability is if you've already tested and confirmed that that printed part will work in that application. So that's where, by having an initial design done in an additive manufacturing format, you're saving yourself time and you're saving money to tool up full production, but then you're giving yourself flexibility down the road once it reaches full production for any specials, any one-offs, or any disruptions that may occur. Now let's say we have this new design going down the line and it requires a new fixture. Again, this is a perfect example where you want to print that fixture, but let's talk a little bit more about jigs and fixtures in general. How many of those things are sort of works of art? And by works of art, I mean it's the only one in existence. There is no plan to be able to recreate it. It's heavy and bulky, and it's kind of the secret sauce to making everything work. By 3D printing your fixtures, your jigs, your tools, whatever, you're going to be able to quickly replace those. And if it's a one-off job, you can confidently throw it away without sort of thinking that you're throwing away some masterful piece of artwork. Also saves a lot on storage. The fixtures end up being a lot less heavy, but still very strong and stiff. And so there's a lot of benefits. Once you go digital with a lot of your manufacturing, you can really start to see a lot of benefits in your fixturing and your assembly processes by using those additive manufacturing technology. Now let's take another one, maybe packaging support. Maybe your customer needs this thing to be shipped in a very rugged case, and so you can go in and actually print things that will hold the system together. Maybe you'll print out very special snap-in covers, dust covers for the open ports, or thread supports or something like that. A lot of times there'll be, in the packaging support department, there'll be things like edge protectors, right? The little plastic bumpers that sit on the edge of a part that would help them to stay intact during shipping. But they're almost always generic. They never actually quite fit just exactly how your product is made. By using an additive manufacturing solution for little bits and bobs and packaging support like that, a couple things happen. One, they fit exactly on your part, meaning they don't, you're not compromising, you're not have to tape that thing on. It'll snap right on and fit really well. But also, those packaging support pieces that can be printed kind of whenever, however, that gives a lot of flexibility to that department, that additive department. And so when they don't have quite as many things to print, they will throw a handful of those things on there and they'll optimize their cycle times. So in other words, if you've got a print that's going to take 14 hours, it's going to take through till tomorrow. But if you could make it last 20 hours or 24 hours, you could take full advantage of the entire day printing nonstop, and you would be there the moment it was ready to be changed over for the next job. So by having little simple things that you think, well, there's no ROI there, it actually ends up being a really convenient thing to have in additive. And it's another example where you would never consider it until that additive solution and that additive service center becomes available and running and fully operational. Now, the last one I want to talk about is a supply chain disaster, which is something we never really would have even considered prior to all of what's going on this year. And so let's just say, for the sake of example, that you have maybe 10% of your vendors completely go under, or 10% of your production lines have too many people gone and they can't function, and you still have critical services that need to be produced so that you can continue to ship products and operate at a normal level. You can't let that minority of component sources shut down the majority of the operation in your company. Well, that's where printing really shines. And we've seen that with protective gear and everything else. But in your organization, you need a little bit more time. You need a little bit more experience. You can't buy 10 pieces of equipment, put them in a room in your company, and immediately start switching over your capacity. You need to go through the process of getting it designed for additive. You need to get the testing done, the verification. You need to teach your people how to print and how to design for these machines so that they work. But once that starts happening, you'll only be amazed at how quickly things take off. And you'll get to the point where you've got this complete sort of redundancy in most of your production, where you're going to be able to print or produce through normal tooling the same parts for your products quickly and easily. The big takeaway here is we're not trying to replace anything in your company, except maybe that manual mill in the R&D department that nobody uses anyways, because you're probably missing tools on it. Additive manufacturing will simply expand and support everything you do, and it provides one more tool, but a very powerful tool for your engineering team to be able to use to solve problems. And what we find is once it's in your back pocket, you'll realize just how much you need to use it. And Markforged provides a complete solution set. This is the only platform that allows you to print in plastic, through to composites, through to metal parts, so that you can scale in any way you need to scale and create the capacity that fits your needs. There won't be any compromises along the way because maybe you've hit a limit or something like that. But think about how you want to break it all down. Depending on how you set it up will determine what kinds of machines you might need to buy first. So I'm generally seeing a lot of companies that as they get going, they create a dedicated additive department, very much like a department in the production group, like a paint line or a CNC shop. And that group becomes sort of your solution center for that production capacity. A lot of times people don't think about having sort of a centralized group. They think, well, if I want some in engineering, I've got to justify and buy my own printer. And if R&D wants one, they've got to buy their own machine, and the machine shop's got to buy their own piece of equipment. By centralizing it, by coordinating your efforts, what you can do is eliminate a lot of redundant work. You can consolidate your resources, learn faster, and you can really incorporate everybody's capacity much more efficiently as a company. So really start to think through how you might break that down and who might be running this department. Think about IT department. Before computers, there was no such thing as an IT department. And now IT has a bunch of people and a huge budget. Additive manufacturing is headed in that direction where there's going to be a budget. It will be a shared resource, and it'll become a crucial part of your business. Markforged provides the entire 3D printing platform for industrial use. That includes the industrial 3D printers, the enterprise-level software, and the materials necessary to create those durable end-use parts. To use that platform, it's very simple. Simply upload a part into Eiger. That's the program that slices. It also helps you to get quotes on your parts. You know, if this is a part, maybe it's an assembly fixture or some kind of a special thing, and somebody says, you know, it'd be really helpful, but I don't want to make a big deal out of it and just see if it's something that we could do. Well, really quick, I can make that in a 3D model. Then I could put it in here and find out that it's going to cost $35, more than worth it for what solution it provides. But if this needed to be machined on a CNC machine, it would have been tremendously higher cost and lead time and more hassle and more bandwidth to our people, in which we probably just would have said, deal with it and don't fix it. That feedback, though, and that power to be able to change your part, to change your sparse fill, add composite reinforcements and things like that, allows you to provide better products over time. So let's say you have a part that normally would be made out of tool steel. You could take that part and redesign it to be a composite metal hybrid part. Or maybe that's a part that is sort of expanding the capabilities of an off-the-shelf tooling solution. By understanding the cost, you can make the cost-benefit decision of make versus buy for even the most complex or specialized or custom tooling and come up with a really great part that gives you exactly what you need at the optimum price and delivery. You don't have to be sort of beholden to the in-stock quantity for your providers on any part anymore. And then the distribution of that print of that part can be sent anywhere in the company. You have tremendous flexibility. No matter where the printers are located, as long as you have capacity available, you can send it over and get it printed and quickly make use of that huge capacity that you start to build across your corporation. Everything follows with a single user interface, which is very unique and powerful in the Markforged platform. You'll upload the same part to the same interface and set it up the same way, regardless of what machine or even what material you plan on using it on. And all of it goes through a single source of support and upgrades. Everything is being monitored online, including dashboards so you can see and run reports on exactly what's happening in this additive department, which typically transitions to the question of what about security? Security is central to how this is going to work in a production environment. Some of the first parts ever built, where they kind of built this machine to provide these parts, were aerospace and military. I mean, security is essential in order for that to be a functional potential solution. In fact, Markforged has achieved the ISO 27001 certification for data security. Now, what that means is you can be assured they have very robust processes to keep your data from being lost on a server or from being stolen by anybody, including MLC CAD or Markforged themselves, and you'll know that the uptime will be achieved. Now, there are offline options if that's something that appeals to you, but this platform represents the ultimate solution for additive manufacturing. Coming from the company that basically invented this. This is the world's first carbon fiber printer ever produced, the world's first FDM metal printer with the Metal X, and it's the first and only certification for data security and integrity, all in one platform in one solution set. So I'm going to kick it over to Mike Cady to take us a little bit further into the difference between the composite industrial and the composite desktop platforms. Mike, you ready to take it away?
Marcus, thank you for the introduction, and thank you to the MLC CAD team for having Markforged on today's webinar. My name is Mike Cady, and I'm joined by one of our application engineers, Kevin Smith. As Marcus stated, the back of the brochure does not always tell the tale. Over the next 20 to 30 minutes, it is my goal to provide you with knowledge and information so that you can make well-informed and educated business decisions as you continue your journey to additive and adoption of this exciting new technology. At Markforged, we take a people, process, and technology approach to our business partnerships. Underscored by recent commentary from Deloitte, successfully implementing and scaling additive manufacturing technology to an industrial level, or even to determine whether it is economically justifiable, often requires organizations to consider factors well beyond the additive manufacturing machinery. While technology is an important element, it's the combination of technology with people and process that truly unlocks opportunity in this space for our customers, driving accelerated value realization. So where do you start? I'd like to introduce you to the Markforged AM program framework. This process framework is intentional and has been yielding great results for our customers, big and small, across the globe. Oftentimes, customers are focused on the technology as the starting point. We're focused on the business problem we're trying to solve. Is it top line revenue? Is it taking cost out of the business through supply chain optimization, maintenance and repair operations, et cetera? As we look at the entire ideation to production manufacturing lifecycle, Markforged directly impacts and drives positive business outcomes for our customers throughout that entire life cycle. At the end of the day, Markforged helps our customers improve customer experience, workforce experience, and deliver shareholder value, shareholder return. When we lock in on those business problems with our customers, we then get into, okay, what are the application opportunities or the process efficiency opportunities whereby additive with Markforged and MLC CAD can have a positive business impact on your business. The key in doing so is identifying those application work streams. And once identified and working with our customers, we zero in on what are the required capabilities that our additive platform must offer to address the value at stake or address the business problems to drive the positive business outcomes that you desire or we aim to achieve. Today's conversation is going to be hinged on the required capabilities element of the AM program framework. A key objective is to go through some of those required capabilities that you may want to be thinking about as you make those initial investment selections and decisions in an additive platform. At the end of the day, we want to make sure our customers understand and help us understand what their required capabilities are and how we are going to test to validate the technology platform. If we put a part in your hand today, how are you going to test it in your environment? And how are you going to validate, call it the technical win, that's going to drive the positive business outcomes, which will drive the value at stake that we're ultimately going after? So technology is the enabler. As Marcus kicks things off, we are here today to discuss our industrial composite and desktop composite platforms. We find that this is a decision point for many and most of our customers as to where they actually get started from an investment perspective. We thought we would start with some platform positioning to help level set the audience on the web conference today, to provide some high level understanding of where these two platforms sit in a real world environment. The desktop composite platform sits in the designer's workspace. Quick iteration, one-offs, testing. Process is manual. The industrial composite platform sits in the plant floor, shared space, factory applications across, the entire ideation to production manufacturing life cycle. The industrial composite being on the factory floor in a shared workspace environment, this product was designed with advanced automation capabilities that minimizes human interaction, which gives you a seamless, reliable, and repeatable experience with exceptional accuracy of plus or minus 50 microns. The X7 is a hands-off experience. So what are your required capabilities? And this is where we're going to spend the balance of today's conversation. As you look at where to get started, is the desktop composite platform right for you, or is it the industrial composite platform right for you? What I would recommend is focus on the required capabilities that are going to deliver the business outcomes that we are collectively aiming for as we start our additive journey together. So let's get into it. The industrial composite versus the desktop platform. What we've done here is provided 7 different, let's call them discussion point or platform areas for us to jump off of into a required capabilities discussion, to then provide you with things to think about as you are evaluating technology and where that insertion point is to get started. So from a comparison perspective, let's just talk about 2nd versus 4th generation technology. The X7 we've implemented new and improved hardware across the entire system architecture. The X7 offers a full sensor suite that drives automation and quality. And as you can see, we've hit on a couple of these areas here. We'll get deeper into this from a platform perspective as we talk about required capabilities today. But as you're thinking about where you invest your dollars, the industrial composite platform is a fourth generation platform that we continue to invest in and develop off of. The desktop composite via the Mark II is one of the best products we've ever brought to market. It's highly adopted worldwide by our 15,000 customers. It's a great product, but again, its purpose is to sit in that designer's workspace versus the plant factory floor. So at the end of the day, when you look at reducing labor costs, improving yield, and reducing downtime, or I should say maximizing utilization and uptime in a factory floor environment, the industrial composite X7 platform truly is the platform that shines to address those use cases that are important for our customers. Now that you have just a macro level understanding of the platforms and kind of where they sit, let's get into the required capabilities. I'll talk to capabilities of both of these platforms. My goal and objective here is for you to be thinking about, are these required capabilities of mine that I have for my initiative? And if so, what are they? And that should lead you down the right path from a decision-making perspective of, do we begin with desktop? Do we begin with industrial composite? So the industrial composite platform offers laser capabilities and production monitoring capabilities that are not offered on the desktop platform. Markforged has instrumented the industrial X7 platform with a full sensor suite, including motor encoders and a calibration laser, so accurate it can compensate for single-digit changes in room temperature. The 1 micron laser micrometer on the print head serves a variety of functions, including an adaptive level bed scan. Before every print begins, the laser scans the print bed and creates a map of the slight variation in flatness, which it then references during the first 5 layers of the print to ensure a perfect part. So every print starts off successfully without having to manually level the print bed. On the desktop composite platform, we talked about it being manual. The user has to manually level the print bed. The laser bed leveling utility takes essentially the guesswork out of shim leveling required on our desktop series. And frankly, is very important to our customers who are doing large builds. Better leveling equals better parts. In addition, the laser also helps the printer perform what we call a pre-print calibration, which measures the actual print bead width versus expected and then adjusted accordingly. So active print calibration, a topographic map of the print bed is created, and the printer automatically adjusts the Z height during printing, during the first 5 to 20 layers to give you the best bottom surface every time. While the bottom surface on the Mark II is usually very good, it is never as good as the X7. Lastly, the laser is used to perform what we call an in-process inspection that scans parts mid-print to ensure dimensional accuracy for the most critical tolerances. If you are printing a part with critical features or dimensions at any layer of a print, you can assign a scan of the part to physically measure the part against the expected geometry. The scan will return a report to your email showing the as printed geometry compared to the input geometry, i.e. the STL file, so you can verify the quality before the print is finished. Only Markforged offers micron level laser inspection for closed loop calibration. If industry leading quality and accuracy is critical path, or said differently, is a required capability down to the automation that I just walked you through, only the Markforged X7 industrial composite platform offers this micron level laser inspection for closed loop calibration, delivering the repeatable experience that you may be looking for. Furthermore, the in-process inspection laser can also be used to measure distances and dimensions, which would be difficult to reach with CMM or traditional measurement methods. Think like internal cavities or parts with complex geometry. You won't get this with the desktop composite platform, only on the industrial composite platform. So again, another required capability to think about is again, dimensional tolerance, accuracy, geometries, and what is the outcome that you're looking for. In summary, the X7 capabilities via laser bed leveling, adaptive bed leveling, and the bead width test that we walk through deliver improved extrusion, stronger first layer adhesion, smoother bottom surface, and faster build leveling, driving overall increased print reliability and printer utilization and uptime. The X7 industrial composite platform also offers video as a sensor, i.e. a build camera, so we can quickly check prints remotely. One use case might be, it's Friday, 4 o'clock. I want to get home, start my weekend, but I've got a large build that has to be done by Monday morning, or I've got a sizable part that needs to be done by Monday morning, for example. I can start that print before I leave, and I have full visibility into the printing process from start to finish remotely, so I can check in periodically just to confirm that the print is moving forward, and it'll be ready to go Monday morning when I come into the office. In addition, the second use case, leveraging the build camera, might be, I've left the office already for the weekend, and I'm at home. I'm contacted by the factory. Hey, Mike, we've got to get this part done. Can you mock something up? Can you get a print kicked off? I've now got the ability to remotely view the print bed and the platform to make sure that it's ready to go, nothing's printing, and I can mock something up, import the STL, configure my print, and send it to the machine for printing. So again, it gives me remote visibility. Regardless of the use case, I've got remote visibility anywhere I am to check on a print or see if the print bed's clear to kick off a new print. That's only on the industrial composite platform. An additional capability offered on the industrial composite platform that is not available on our desktop composite platform is an AI-powered software to empower the equipment to reprogram itself to make perfect parts. Markforged recently announced the world's first closed-loop AI, artificial intelligence, for 3D to improve part accuracy. Essentially, what this software capability does is it creates a continuous feedback loop to make parts more accurate. We analyze the design, we compare it to a scan part, and it automatically adapts the end-to-end process to produce and inspect parts. So with each iteration across the globe, part accuracy continues to improve with fleet learning on a global scale. And as a result, our system learns continually and adapts to variations in the process over the lifetime of your investment. The third required capability that we'd like you to consider is hinged on materials, not necessarily what those materials are, but what they provide. And I'll get into this. So at a high level, the industrial composite platform and the desktop platform both offer the Markforged unique continuous fiber process that has created the hyper growth and uniqueness in the additive market for Markforged that draw customers to Markforged. Both of the platforms allow us to reinforce with continuous fibers, i.e. Kevlar, fiberglass, high strength, high temperature fiberglass, and carbon fiber. Future material development will only be available on the industrial composite platform. So we'll get into this momentarily, some of the newer materials that we've released, as well as some of the materials that are incoming. Again, you're only going to get those on the industrial composite platform. So your needs today may not be your needs of tomorrow. So one of the things to consider is not only what you need now, but where is your business going? And if there are potential future developments from a materials perspective, those are only going to be available on the industrial composite platform. From an education perspective, the matrix material we use is called Onyx. It was developed by Markforged. By definition, it's a composite itself. It consists of a mixture of nylon and chopped carbon fiber. Interestingly enough, the chopped carbon fiber was not added for strength specifically, but for stability and printability. The short strand carbon fiber helps prevent the drastic changes as the material is heated and cooled, thus resulting in beautiful, accurate parts. Onyx by itself is actually fairly strong, 20% stronger than ABS, about 40% stiffer. There are many cases where Onyx itself can provide adequate characteristics for a final functional part. However, the dramatic increase in strength comes from the addition of our, as I mentioned, unique continuous fiber process. So Markforged technology has the ability to integrate 4 different continuous fibers, and each of those fibers has a unique value proposition to help solve your problem. So when we talk about required capabilities, you may want to be thinking about, is strength important to me? For example, when leveraging our unique continuous fiber process in carbon fiber, you print parts that exceed the strength of 6061 T6 aluminum. Is impact resistance and energy absorption for high wear applications a required capability of mine? If so, Kevlar may be a great continuous fiber to leverage to meet your application needs. Do I have high temperature scenarios that are a great fit for high strength, high temperature fiberglass? The key takeaway here is that each of these fibers were selected and engineered to allow you as the user to tackle a wide variety of problems. The strength that Markforged delivers via the industrial composite platform and the desktop platform is truly unique to the industry, and it's what has driven the hyper growth behind Markforged. But as you're looking at required capabilities, understand that both of those platforms offer, what has made our brand, which is strong parts in a manufacturing environment across a wide variety of applications. I mentioned earlier future materials development. For example, we just released a flame retardant version of Onyx. The Onyx FR material is only available on the industrial composite platform. In the first half of 2020, as we move into Q3, we're also going to see an Onyx ESD safe material that is highly suitable for electrical components and tooling. Again, new materials coming downstream will be available on the industrial composite platform. Let's talk about size and build volume. The desktop platform via the Mark II, XYZ dimensions are shown here. Here are the industrial composite, X dimension, Y dimension, and Z dimension. We bring those two together. This gives you a visual as to the build area and build volume capacity differences between the two platforms. So one of the required capability conversations you may be having is, based upon our application scope and application profile, will the desktop composite platform meet the need, or will the industrial composite platform meet the need from a size perspective in alignment with the applications that we're thinking about today and tomorrow? In summary, the industrial composite platform, in comparison to the desktop platform, produces greater end part quality, less complexity, and less assembly. Please allow me to show you some examples of that. Here's one. This was a 14-hour print on a Mark II. It's a batch job, multi-up, one part, quantity of 6. In comparison to the industrial composite platform, in 24 hours, I can now print quantity 16 multi-up batch job versus 6 and 14 hours. So as you can see, I'm more than 2x the productivity rate with an X7 industrial composite investment than I am on a desktop composite platform investment. The required capability conversation here is, again, how many users am I have? What is the application scope and profile that's going to drive the value at stake that we've defined? And what type of capacity am I going to need to deliver on that value at stake, right? So oftentimes our customers really zero in on build volume, batch jobs, how much time is it going to take, and the conversation shifts to a capacity and utilization required capabilities discussion. Again, the back of the brochure, you've got the same unique continuous fibers, but when you get into the platform, these platforms are designed to do many different things. So again, just another example of a required capability that you may want to consider as part of your decision-making process. Quality. So Markforged has been known for best-in-class surface finish across all of our product platforms, whether it be plastics, composites, or metal. Specifically, as we look at the industrial composite versus the desktop composite, the industrial composite does deliver higher resolution, a smoother surface quality, reduced layer lines, and improved complex curvature, as you can see here on the right. The Mark II at its best is going to be able to print at 100 microns. Again, manual intervention is going to be required. On the industrial composite side, we can deliver improved accuracy as well as repeatability through a hands-off automated experience. So again, if this is something that's going to be utilized by a designer or two in a shared workspace, the Mark II may be just fine for the needs. But if we're talking about a shared workspace with many users, lots of hands in the process, the repeatable automated experience may quickly become a required capability of yours in the context of what's important from a decisioning perspective. Again, just want to make some clear call outs in the context of surface finish, automation, and repeatability. Print speed. The X7 is now 2x faster. Our X7 platform is now shipping with a feature called Turbo Print. And at the end of the day, faster print speed means reduced cost, it means efficiency, and increased utilization. Continuous product improvements. Both the industrial composite platform and the desktop platform have undergone significant hardware improvements over the last 12 months. From a software perspective, I think for the folks here on the webinar today, you're starting to see a theme of additional investment, innovation, and development is truly going in and being delivered via software and materials. And all of that development is being put into our X7 platform. So again, you got to ask yourself, right, in this example, right, increased print speed, improved accuracy with closed loop AI, additional materials that unlock new applications. Maybe these are not required capabilities today. Maybe they will be tomorrow. And other additional materials that are in the roadmap, those are all coming down and being delivered on our industrial composite platform. Quick summary on the industrial composite platform as we've talked through today. In summary, what sets the industrial printer apart is the level of automation incorporated into the machine. This automation exists to provide a seamless and reliable experience to the end user and provide exceptional accuracy. As we discussed, the X7 routinely prints parts with an accuracy of plus or minus 50 microns. The laser micrometer on board on the print head serves a variety of functions that we discussed today, including adaptive level bed scan. Before every print, that laser is used to measure the bed flatness, which is then accounted for in the first 5 layers of the print to ensure that perfect part. That laser also helps the printer perform that pre-print calibration as well as the in-process inspection we reviewed. The X7, as well as the Mark II, are both capable of printing all of our continuous fiber materials. However, the X7 does offer the Onyx FR and will offer the Onyx ESD here this year in 2020. I hope this overview of the industrial composite versus desktop composite platform has been educational and informational and provides some insight and perspective around how we approach the required capabilities conversation with our customers. Moreover, I hope it's been beneficial to walk through these differences in our two platforms, because again, the back of the brochure does not always tell the tale. And I hope that there was at least one or two things that you walked away from this conversation today, whether it be from, the perspective of how you're approaching additive or thinking about additive, or maybe it's specific to Markforged. Maybe you are in that position right now where you're trying to make a decision on, man, is the industrial composite platform or the desktop platform the right decision, for me to make to get started? My goal is to provide you with some things to think about, and I hope that we've achieved that today's conversation. The thing that I'll leave you with on technology is, as you look at required capabilities, make sure that you're thinking about objective metrics and how you would test to validate that the platform can deliver on the test metrics that you deem are critical path for the solution platform that you're investing in. And lastly, please don't forget about the people process piece. I would argue that the people and process is as important, if not more important, than the technology. The technology plugs into the wall, it gets green blinky lights, and it works. What happens when you make the investment and you deploy the technology? Are you thinking about how you operationalize that technology? Are you thinking about the user experience? And is there a knowledge gap or a potential adoption challenge? Because again, additive is new to many, and really it starts with designing. So the thing that I'll leave you with is Markforged recognizes this, and in partnership with a $9 billion tier one auto supplier, 2 years ago, we went on this journey together and created Markforged Additive Manufacturing University. And the core theme behind it was, how do we drive additive knowledge and additive adoption across the manufacturing life cycle into the cultural fabric of the organization? And the answer is, we created this customer certification program that spans how do we maximize and future-proof the investment? How do we upskill the workforce? How do we enable this at scale? How do we inspire, selecting the right applications and inspire innovation around how we solve business problems? Our courses are designed to drive critical additive skills across selecting high value applications, designing for additive, and then, print lifecycle management, business case development, et cetera. We don't stop at the technology. It's all about post-sale engagement and ensuring not only are our customers making well-informed and educated business decisions up front, but also having a plan for execution on the back end and are set up for success. So on behalf of Markforged, thank you to NLC CAD and for the customer population that's on today's call. I'll turn it back over to Marcus. Take us home, my friend.
Thank you, Mike. That's great information. I've always kind of been struck by how elegantly Markforged desktop solutions were able to create strong parts. And the desktop platform was built from the ground up to print these parts that are stronger than any 3D printed parts have ever been. And to this day, they haven't been beat in that composite space. The industrial platform is really designed to take that into full production, where the challenge is more than just make a strong part, but to make several strong parts with high tolerances, high reliability, with speed, with lower operating costs, so it can become a valuable part of modern manufacturing.